Okay, I wanted to show you this GeoGebra quick little demonstration here. And I gave you a blank pad to draw in also if you wanted to, but anyway, this one I already did. So what we're going to do is start talking about the shortest distance. Okay, so in this case here we have the shortest distance between 2 points is what we want to try to prove. Alright, now you already know that the shortest distance between 2 points is a straight line, right? Or a line segment, because we know all lines are straight. So that's kind of called like a distance that if you wanted to know how to the shortest distance from here to Columbia City, right, you might say, well, I would just probably travel on Highway 30, when actually if it was your house to, say, the mini mart in Columbia City, so you had 2 distinct points, then that might not be the quickest way, right? Because you might have to make some turns, and Highway 30 might not be right where your house is, so it might not even be a straight shot. It probably has, something that would have to curve around. So in that case, we would say that distance as the crow flies, because a bird doesn't have that kind of obstacles in the way, right? It could just go and fly. So the shortest distance between 2 points, distinct points, as you know, is going to be that line segment that contains those points. So what I did was I drew AB to show you that that measurement was 8.46. So if this was your house and this was the mini mart in Columbia City, then that would represent that distance, right? I can move it over here to make it look a little bit more dramatic. Then I put this point C down here, which says, well, what if I have to go from here and then over to there, right? Well, that's obviously, by looking at the sum, by the way, which is these two things added up, is a longer distance, right? And we can move this wherever we want, but it doesn't matter. It's always going to be bigger than the AB distances. Even now, it's pretty close, but it's still just a little bit bigger. And it's not actually equal until you get almost on top of that thing, right? Then it's pretty equal. Right now it's just a little bit of rounding errors there, alright, but right there it's equal, which goes to show that that shortest distance, okay, is along that segment. We proved that dynamically, right, that is definitely the shortest distance. Now the other one that is of interest to us, and what I'm going to do is go ahead and just kind of get a new drawing. Actually, you know what I'm going to do? I'm just going to scoot this, I think. And we don't need it. Alright, we'll just scoot it out of the way. So now I'm going to say, well, what if I have a point here, and I have a line here, right? And I want to know the shortest distance from this point to this line. Where would I go? Right, that's what I want to know. I want to know the shortest distance. So to check that out, we would put a point on object here and just draw a segment and then measure that distance. And I can just click on this here if we want to. There it is. Now I can show that there's my distance, right? So it's 4.12 if I go straight that way. But if I slide this G over, we notice that it's getting smaller, right? And now it's starting to get big again. So I want the shortest distance here. And it looks like it's right about there somewhere. Right about 3.27. Okay, that's the shortest distance. And that might make sense to you too, because you're just going straight to that wall, right? Or that line. You're not going at an angle. That wouldn't make any sense. That's definitely going to be longer. We want to go straight to it. To show what that exactly is, we're going to draw a perpendicular from this point to this line. And you can see now that this G point is actually shortest. Why is this not a perpendicular? It's shorter, right, at that perpendicular right there. So when we have a perpendicular from here down to that line, that's going to be my shortest distance. A nice perpendicular angle right there, a 90-degree angle, perpendicular distance. That is the shortest distance from there to there. Okay. So, and you could duplicate that if you want to. You could pause the video and go back and try it out. Alright, but those are two things. The one that we're more interested in, and now I have this line here, so I'm just going to get rid of it. I don't want it anymore. The one that we're more interested in is the shortest distance between a point and a line and another point. Okay, that's the one that we're most interested in. But we'll probably take a look at that on Monday and examine that. So I just wanted to show you that those two are the two shortest distance problems. And then you can spend some time working on some stuff you need to get done. So that's it.